Today, we are going to discuss something called dynamic ARP inspection. So basically in the last class, we have started something called L2 security, that how you can provide the layer 2 security features on your switches. So in the last class, we have discussed about the DSCP snooping feature and why we were using DSCP snooping feature, guys. Anybody? We were using the DSCP snooping feature so that we can protect our network from DSCP spoofing attack, if you remember. And to perform DSCP spoofing attack, the attacker might perform DSCP starvation attack, right? That's what we discussed in the last class, and we saw that the DSCP snooping feature is mitigating the problem of DSCP spoofing. Now today I'm going to talk about the dynamic ARP inspection. Now first of all, to discuss about dynamic ARP inspection, I would like to create a topology. With reference to the topology, we'll talk about the dynamic ARP inspection. Why it is required on the switches. So let us take a router, a switch, then let's say that's your DSCP server in your network. Then you are having multiple LAN users. Fine. So that's your router, which is obviously the default gateway. Fine. And with this router, the ISP is connected. I'm going to assume that this is the DSCP server on which a pool has been created. The pool name is ABC. Fine. And it is configured with the network 10.0.0.0/24. So that means how many possible IPs are available? Total 255. You can say there are 254 valid IP addresses, right, in this particular pool. Now, this DSCP server is having the IP address 10.1. Fine. Let's suppose this router interface is having the IP address 10.2. And all these are your users, user 1, user 2, user 3, user 4. So I'm just assuming that this particular user 4 is just an attacker in my network, or you can say the unethical user, the illegitimate user. Fine. So in the last class, we discussed that with the help of DSCP spoofing, with the help of DSCP starvation, with these techniques, the attacker may try to the attacker will try to get all the IP address from the DSCP server, right? Basically, it will try to vacant the pool on the DSCP server. And when the legitimate user will try to request for the IP address, the DSCP server will not respond. Why? Because the attacker has already consumed all the IP addresses with the DSCP starvation. And with the DSCP spoofing, the attacker will give the fake IP address. Basically, the attacker system will behave like a DSCP server, and the actual user will get the IP from an attacker rather than getting the IP address from the actual DSCP server. Now, let's talk about the why do we require the dynamic ARP inspection. So let's discuss a problem. Let's suppose that these users, user 1 has been configured with the static IP 10.3. Fine. The user 3 has been configured with the static IP 10.6. Fine. These have been configured with the static IP address. Now try to understand. Let's suppose that this user 10.3 wants to reach internet. So I hope everybody is clear that whenever user machine would like to reach out of its own network, then ARP request is always generated, and ARP request is always generated for the default gateway which is configured on the endpoint, right? So let's assume that the default way configured on the endpoint is 10.2. Same goes for 10.6. The default gateway configured is 10.2. Fine. Now, and this attacker or this ethical user, this legitimate user wants to reach to ISP. Let's suppose that this user want to open www.google.com. Fine. First of all, the DNS request will be sent. DNS reply will be received by the end machine. Before that, there is something called ARP request. Now try to understand, when this end machine will generate an ARP request, what will be the source IP? 10.3. What will be the destination IP? 10.2. What will be the source MAC? Let's suppose the MAC address of this machine is A. MAC address of the router's interface, which is the default gateway, is B. Fine. So source MAC will be A, destination MAC will be what? Broadcast MAC address, we know that all the characters are going to be F. So when this ARP request will be sent by the end machine to the switch, switch will receive this ARP request on this port, switch will check the destination MAC, and based on the destination MAC, switch will broadcast the ARP request from all of its ports, right guys? That's what happens. Now, if everything is fine in the network, all the users are legitimate user, fine, there is no illegal activity going in your network, so obviously it is the default gateway, that is your router will respond back with an ARP reply. What will be the ARP reply? ARP reply will be 10.2 source IP, destination IP 10.3, source MAC B, destination MAC A. ARP reply will be unicasted to the end machine only. This is how the packet flows. Now, let's suppose that this user wants to reach to www.google.com. Obviously, the end machine first of all will generate an ARP request for the default gateway. The ARP request will be sent to switch. Since ARP request is always broadcasted, switch will broadcast this ARP request from all of its ports, right? That means the ARP request will be received by the DHCP server, by the router, by these end user machines, and also the attacker. Fine. Now, let's suppose that this attacker has spoofed its own IP address. Basically, let's suppose that this attacker was having the IP address 10.4, but with some spoofing techniques or with some tools, okay, basically, he has generated, this attacker has generated an ARP reply, fine, on the behalf of default gateway. This attacker has generated a fake ARP reply. The source IP is what? Because it has been generated for the default gateway 10.2, destination IP 10.3, source MAC. Now the attacker will provide its own MAC address. Let's suppose the MAC address of the attacker machine is C, destination MAC A. So basically this ARP reply has been generated by the attacker, but not the default gateway. Fine. This attacker will give the ARP reply. ARP reply will be received by the switch. Switch will forward to the end machine. Now, when end machine will send any user traffic, there is a HTTP, there will be a source IP 10.3, there will be a destination IP. Let's suppose that google.com is having the IP 8.8.8.8. There will be source MAC. Source MAC will be what? A. What will be the destination MAC? Obviously, the default gateway MAC address is always added to the destination MAC. So C. Now, when this traffic will be forwarded to the switch, switch will forward it to the attacker. Fine. And now, what attacker can do? Now, attacker can forward this traffic to the ISP. and basically he can capture all the traffic and can see what traffic is being forwarded by the user. Or this attacker can generate a fake website. Fine. And when this user will try to enter the credential, the attacker will get all the credential. So basically the whole logic is that the unethical user in your network may send the ARP reply, okay, to the legitimate user. So this is something called ARP spoofing. ARP spoofing means that the actual ARP reply has not been generated by the actual device, but it has been generated by another device which is not supposed to generate it. Is it clear to everybody?
Yes,
Mr. Amit, are you clear with this? Tarun, Miss Athira?
This is clear, but I just want to confirm that whether the attacker is using the same pool IPs or they can use another public IPs or some private IPs also.
Athira, right now we are just talking about the security features within your own LAN network.
Okay.
Okay.
Sure. If it's in the public, so how can you just explain me that?
If that's in public user.
Yeah.
See, for the public user, there are other things which we are not supposed to discuss in today's class.
Okay.
Sorry. We'll talk about it.
Okay, sure.
So no queries from anyone. So basically, to overcome this problem of
Prashant, basically, sorry,
yes,
I would like to interrupt here. I want to understand the packet, the packet flow over here again, please.
Okay. First of all, you all should be clear with the basic packet flow in your network. That's 10.1. That's
sorry, my question is a little bit out of concept. Again,
Mm-hmm.
Let's see, somebody is asking me this. Suppose we give interviews. It's a common question for everybody who is sitting over here in the class. It's a common question for everybody. If we go to the interview, they ask us, okay, tell us XYZ. This is the concept. What would be the packet flow? So that is a different scenario. But what I want to understand, so you was telling me the basic we have to understand basic traffic flow. So please let me know what.
Tarun, right now I have not. Right now we are just discussing about the basic packet flow. I have not introduced any new terminology here. Just let me just explain the same scenario again.
Okay.
That's your switch. That's your default gateway, which is configured with the IP address 10.2. Then there is a user which is having the IP address 10.3. That's your legitimate user. Let's suppose that there is an attacker in your organization which is configured with the IP address 10.4.
And he have spoofing XYZ tool or something like that.
Yes, absolutely. See, try to understand. We know that ARP request is always generated for the default gateway, right, Tarun?
Right, correct.
So let's suppose this legitimate user has generated an ARP request. The source IP will be 10.3, the destination IP will be 10.2 because this is the default gateway configured on the end machine. Fine. Correct. Source MAC will be, let's suppose that's a MAC address A, the router interface MAC address is B, and let's suppose that the attacker is having the MAC address C. Fine.
Okay.
Source MAC will be A, destination MAC will be broadcast.
Yes, for sure.
Now, the user will send the ARP request. Switch will receive it. Switch will check the destination MAC. Destination MAC is broadcast. It will be broadcasted to all the device. Fine. Right. Now, the only thing that I'm trying to tell you is that let's suppose that instead of now this ARP reply has to be generated by the router only, right? The ARP reply has to be generated by the router only. But let's suppose that with some spoofing techniques or by any unethical means, this attacker has generated an ARP reply. Now it will generate the ARP reply on the behalf of default gateway. Try to understand, the default gateway is what? 10.2. So source IP will be 10.2, destination IP who has generated the request 10.3, source MAC. Now it will provide its own source MAC instead of providing the MAC address of the default gateway.
Confusion.
Yes.
10.2 is the default gateway, right?
Right, absolutely.
So he is generating the request from the 10.2 for the IP address.
Yeah, that's what I'm trying to tell you.
Okay.
That's okay. That's what I'm saying. That let's suppose the attacker in your organization might be using some unethical tools, and with the help of those tools, the attacker is already generating the reply on the behalf of the default gateway. Clear, Tarun?
Clear.
Now the destination MAC will be what? A. The ARP reply will be unicasted, so it will forward to whom? To the end machine. Now when end machine will try to access any website, fine. The source IP will be 10.3. The destination IP, let's suppose it wants to move to any IP address over the internet. That will be the destination IP. Source IP will be its own, source MAC will be its own MAC address. And what about destination MAC? Destination MAC is always will be the default gateway MAC address. So in the ARP reply, the user machine received the ARP reply having the MAC address C. So the destination MAC becomes C. Now when the user will forward the traffic to the switch will forward the user traffic to the attacker instead of forwarding to the default gateway. Are you able to understand, Tarun, now?
Got it.
That's what it is. So basically, to overcome this problem, or you can say basically we want that only legitimate user should be providing the ARP request or the ARP reply. So for that problem, we came up with the solution called dynamic ARP inspection. Now, any queries from all of you?
So Prashant, might be you may come further if in this concept, but I just wanted to make it clear that how it is different from like a trusted and untrusted port. Earlier we used the trusted port, right?
Yes, absolutely. Mr. Amit, in the last class, we discussed about the trusted and the untrusted port for the DSCP when you want to get the IP address from the DSCP server. But right now I'm talking about the ARP request.
Okay, understood.
Okay. Any more queries? Now let's move forward. Now basically we have discussed about the problem. Now I told you that the solution is what? Dynamic ARP inspection. Fine. Now let me tell you, this solution dynamic ARP inspection is always implemented with DSCP snooping feature. Fine. This solution dynamic ARP inspection is always implemented with the DSCP snooping feature. Now I will again create that scenario. We'll talk about the DSCP snooping and how the dynamic ARP inspection works. Fine. So again, considering a router, switch, users, server. User 1, user 2, user 3, that's the default gateway router. Now, obviously, the DSCP server will have its own static IP. The default gateway also will have its own static IP, right? So let's suppose these are the IP addresses configured on the server and on the default gateway. Now, these are your endpoints, user 1, user 2, and user 3. Try to understand. Now, let's suppose that you have enabled the DSCP snooping feature on the switch. Now guys, what DSCP snooping does? DSCP snooping feature makes sure that the offer message, right? The DSCP offer message should always be received from the legitimate server. So what happens if I enable the DSCP snooping feature on the switch? Whenever switch will respond the offer message on any of its port, the switch by default will drop the DSCP offer message, right? So what we can do in that scenario, on the port of the switch where the actual DSCP server is connected, we can make that port as the trusted port, so that the switch will always going to receive the DSCP offer message only on that port which is trusted. That means if this is my attacker, let's suppose that when this user will generate a discover message, the discover message is always broadcasted, DSCP discover message. Now when attacker will try to send the IP address in the offer message, it will be dropped because this port is untrusted. So you enable the trusted feature only on that port of the switch which is connected with the DSCP server. I hope everybody is clear up to here that this is how the DSCP snooping works.
Yes.
Fine. Now, so I have enabled the DSCP snooping feature on the switch, and I have configured this particular port F0/1 of this switch as the trusted port. Fine. Now, all these users, the user one, let's suppose from the DSCP server, it has got the IP address 10.3. Fine, guys. Let's suppose the another user has got the IP address 10.4 from the DSCP server. But let's suppose that this is not my ethical user. Try to understand. Fine. Now, so whenever, since the DSCP snooping feature is enabled on the switch, what happens? The switch creates a DSCP snooping binding table. So basically in this table, the switch is going to have the information. Let's suppose this is interface F0/2, this is interface F0/3. Let's suppose this particular MAC endpoint is having the MAC address A, it is having B. So what happens? In this DSCP snooping binding table, the switch will create an entry that on F0/2, the DSCP message have been forwarded, DSCP offer message, and on this port, the user has been provided with the IP address 10.3 and it is having the MAC address A. Similarly, in the DSCP snooping binding table on the switch will have another entry that on port F0/3, a DSCP IP has been given and the end machine is B. Fine. Are you clear up to here, everybody?
Yes, Prashant.
Yes.
Okay. Now try to understand. Now along with the DSCP snooping feature, I will also enable dynamic ARP inspection feature. Now what does this feature says? If you enable this feature on the switch, then switch will drop all ARP request and reply from all the ports. What happens? That if I enable the dynamic ARP inspection feature on the switch, then switch will drop all the ARP request and the reply, whatever it is receiving from any of its ports. Try to understand. Fine. So now what I can do? So this dynamic feature, this is the first condition. What happens when you enable the dynamic RF inspection on the switch. Now, second thing, now now this dynamic RF inspection feature says I can allow ARP request and reply only from those ports which is present in DSCP snooping table. Now, what does the second rule say? Second rule says that if the switch is going to receive an ARP request, try to understand, let's suppose that both the users have received the IP address from the DSCP server, fine, and the DSCP snooping table has created an entry, fine. Now when this user A will try to send any traffic to ISP, obviously the ARP request will be generated. The source IP will be 10.3, destination IP for the default gateway, source MAC will be A, destination MAC will be what? Broadcast, right? Now, when this ARP request will be forwarded to switch, now since the dynamic ARP inspection feature is enabled, the switch will say that I will drop the ARP request and ARP reply from all the ports, fine. But dynamic ARP inspection feature also says that I will allow the ARP request and reply packet only from those ports which is present in the DSCP snooping table. Now switch will check that I have received this ARP request on which port? On F0/2. Is it available in the DSCP snooping table? Yes. Now, and what IP address has been given to the user? 10.3. Now, the switch will check what is the source IP in the ARP request? 10.3. What was the MAC address in the snooping table? A. What is the source MAC in the ARP request? A. So everything is matching as per the DSCP snooping table. So switch will say that this user has received the IP address from the legitimate DSCP server. So switch will assume that the ARP request which I have received is from the legitimate user only. So switch will receive the ARP reply. It will be accepted here. Everybody is clear? Everybody is clear? All of you. Amit, are you clear with this?
Yes, Prashant.
Miss Athira, Tarunji, Santoshji.
Yes, Prashant.
Fine. Now let's talk about this user 3. Fine. Since this user has not received the IP address from the DSCP server, I'm just in my scenario, I'm just assuming it as an attacker. Fine. Let's suppose it is using a static IP address 10.100. Try to understand. Fine. Now, when this user will send the ARP request, the ARP request is always broadcasted. So this attacker will also receive an ARP request, right? Now attacker will come to know that this user 10.3 wants to get the MAC address of 10.2, that is default gateway. Now let's suppose that this attacker has generated an fake ARP reply having the source IP 10.2. Obviously it will generate the ARP reply on the behalf of default gateway. It will show itself as in default gateway. Destination IP will be what? 10.3. Source MAC will be, let's suppose it is having MAC address C. Destination MAC will be what? A, right? When this ARP reply will be forwarded to this switch will first of all check that if the dynamic ARP inspection is configured. Yes. So what does ARP inspection says? Drop the packet from all the ports, but check the DSCP snooping table. Now in the DSCP snooping table, the switch will not find any entry on this port. Will it find any entry on this particular port? No. So in this scenario, switch will drop the packet. As simple as that. So everyone is clear with the theoretical part of this dynamic ARP inspection along with the DSCP snooping? All of you?
Yes.
Mr. Amit, are you clear with this? Tarun? And now we are going to conduct the practical of dynamic ARP inspection. So let me just tell you how we are going to configure our topology. So this is going to be my DSCP server. I will configure a pool The name of the pool will be ABC. And I will configure the pool 10.0.0.0/24. Fine. And this is going to be my user 1. That's going to be my user 2. Fine. We will consider this user as an attacker. Fine. So we will try to provide the IP address to the user 1 through the DHCP server. But with the attacker, we will provide the IP address statically. And we'll see how the dynamic ARC inspection works. Fine. So R2, no. R3, R4, switch, so now let's start the configuration parts. Let's move to R2 first of all. Enable configuration terminal interface is 0/0 no shutdown IP address. Let's suppose that the DHCP server is having the IP 10.0.0.10, 255.255.255.0. Okay. So host name, router 2, which is my DHCP server, and also it is acting as my default gateway also. Fine. So default gateway. Now configure the DHCP on the router R2. So IP DHCP pool. The name of the pool is ABC. Then network 10.0.0.0/24. Then default gateway. I would like to get the default gateway 10.0.0.10. So we have configured DHCP on the router R2 and the IP address is 10.10. Fine. Now move to switch. I will enable DHCP snooping feature on the switch first of all. That's our first step. Because we want only the legitimate server should provide the IP address. So enable configuration terminal. Now what are the configuration of the DHCP snooping feature? Anybody? IP DHCP snooping, then IP DHCP snooping. On which port you would like to configure DHCP snooping feature? On all the ports which belong to VLAN 1, because right now all the ports are in VLAN 1. That's it. The DHCP snooping feature has been enabled on the switch. Now if I will try to take the IP address on this user 1 from the DHCP server, will I get the IP address? Guys, will I get the IP address? All of you. Host name R4 user. Miss Athira. If I try to take the IP address from the DHCP server on this user 1, will I get the IP address now?
Yes.
Yes. Anybody? Mr. Amit? Santosh ji?
I don't think so, because it has
not get till we make the DHCP server
tested.
Yes. Trusted command should I run?
Yes.
Okay. So let's see. I have already executed this command. Do IP address DHCP. Just let's check. Do show IP interface brief. You can see this interface is 0/0. has not received the IP address as of now. Why? Because by default for the switch, all the ports will be untrusted for the DSCP offer message, right? So we need to move to the switch and we need to configure interface E0/0 that you are the trusted port. So you can accept the DSCP offer. Now, will I get the IP address, everybody?
Yes.
Let me just execute this command, IP address DSCP. Let's see. If I execute this command, do show IP interface brief. Have I received the IP address? No. Now, can anyone tell me the reason why I have not received the IP address as of now? Anybody? It will be highly appreciated if someone would like to give the answer. I would like to remind all of you, in the last class, we have discussed something called option 82. If
Option 82 in switch, right?
Right. So we need to run an extra command on the switch. Move to the switch. And what shall be that command? No IP DSCP snooping information option. That's it. And now if I move to the user again, let me execute the command IP address DSCP. So you can see the user has immediately got the IP address unless the DSCP server will not provide the IP address. There will be no entry in the DSCP snooping binding. So Ethernet 0/0, you can see it says that on Ethernet 0/2, DSC snooping binding is there, and I believe that this R4 has received the IP address. Let us just check on the switch. The switch says that on my interface Ethernet 0/2, the IP address has been provided 10.2 to the MAC address this. Okay, let me just check the MAC address of the router's interface. R4 interface E0/0. Let me just check its MAC address once. Enable configuration terminal, do show IP interface brief. Yes, it has got the IP address from the DSCP server only, you can see. Fine, that is why we are having that entry. And let me just check the MAC address. Do show interface E0/0 pipe include burnt-in address. So this is the MAC address of the router R4 interface E0/0. And let us check the switch DSCP snooping MAC address. Are these MAC addresses same, guys? AABB CC 004 3x0. Yes, that is it. So basically, our user R4 has received the IP address from the DSCP server. That's why on the switch, we can see the entry in the DSCP snooping binding table. Everybody is clear up to here? Any queries? I have just performed the last class practical only as of now. Now, let's move to router R3, which is my user 2. Let's configure this user with a static IP. So this is R3. Enable configuration terminal, host name R3 user 2, and here I'll give the IP address manually. Interface E0/0, no shutdown. Let's suppose the IP address configured is 10.0.0.100 255.255.255.0. So now this attacker, or you can say the user 2, has been configured with the static IP. So obviously the switch will not have any entry in its binding table, right, guys? Now let me enable the ARP inspection. So how do you enable the dynamic ARP inspection? The command is IP ARP inspection. Then you need to define on which port you would like to enable the IP ARP inspection. So I would like to enable ARP inspection feature on all the ports which belong to VLAN 1. That's it. Now this particular user has received the IP address. This user has what IP address it has received? 10.2, right? This user has received the IP address 10.2 from the DHCP server. Fine. This attacker has been configured with the IP address 10.0.0.100, which is statically configured. And I told you, once you enable the dynamic ARP inspection feature on the switch will receive the ARP request and ARP reply only on that port which is available in the DHCP snooping binding table, right? Let's move to the switch. Let me execute this command, do debug ARP. Okay. And now from router R2, which is your DHCP server, let me ping 10.0.0.100. The ping is not successful. You can see ping 10.0.0.100 is not successful. And now see, your switch is receiving some messages. Your switch says that I have received an invalid ARP request on Ethernet 0/0 from this MAC address having the IP address 10.10. From DHCP server, ping 10.100 once again and try to read these logs. Let me just copy it. Copy. Fine. So this is the message that we have received on the switch. Now try to understand what does this log message says. This log message on the switch says that the DHCP snooping deny has been occurred. Why it has been occurred? Because of the dynamic ARP inspection feature. Fine. Now the switch says that I have received an invalid ARP request on my port Ethernet 0/0. Now switch says that on the Ethernet 0/0, I have received an invalid ARP request. Why switch is saying that it is an invalid ARP request? It says that ARP request has been received from this source MAC address having this source IP. This is the destination IP, you can see. This is the destination MAC. Everybody is clear? Now try to understand that why the switch is saying that the ARP request which it has received from the server, it is invalid. Guys, I told you that whenever your switch is going to receive ARP request and ARP reply on any of its port, it will check what? DHCP snooping binding table. Now try to understand. This user is having the entry in the binding table because it has received the IP address from the DHCP. But tell me guys, will the DHCP server will ever get the IP address from the DHCP server? No. This is the own DHCP. This is the DHCP server only, right? It will provide the IP address, but it will never receive the IP address from the DHCP server. So that means on this particular port of the switch, it will never have DHCP binding. On this port of the switch is never going to have the DHCP snooping binding. Why? Because it is itself a DHCP server which is providing the IP addresses to the other clients. So obviously the DHCP snooping will never have the entry for this particular port Ethernet E0/0. That's why the switch is dropping this ARP request. You can see. If I execute this command, do show IP DHCP snooping binding, do you see any entry on port Ethernet 0/0? No. So if there is no entry, obviously the switch will drop the packet. Everybody is clear with this? Mr. Amit, Miss Athira, Santosh ji.
Okay.
Yes, very much.
Okay. So what you need to do? So in this scenario, the port of the switch which is connected with the DHCP server, fine, you have to make that port as the trusted port for the ARP packet also, right? What I'm trying to say is that currently this port of the switch is the untrusted port for ARP request and ARP reply. Why? Because there is no entry. So for this particular port of the switch, I need to make some configuration so that the switch should accept the ARP request and ARP reply on this particular port. Is it clear to all? Please, everybody is requested to be proactive. If you have any queries, you can let me know. Else, we will configure this particular port of the switch as the trusted port for ARP packet.
Hi, Prashant.
So move
Can I
to the
ask-
switch.
Hello.
Yes, Athira.
I want to ask one question actually.
Athira, your voice is little low. Can you be please a little loud?
Hello.
Yes, yes, yes.
Okay. For route user one, we are receiving the IP from the SCP server, right? So how can we
Absolutely.
get? So then how can we get if this port is not trusted? If it's not in the binding table, then how we can get the DHCP IP from DHCP server to user one?
No. Athira, there are two things. I think you got confused. See, in very simple terminology, fine, that's my user, that's my DHCP server. Fine, just try to understand. The first point is I have enabled the DHCP snooping feature on this switch. Fine. That means all the port will become the untrusted for what? For DHCP offer message. So I have to configure this port as a trusted port for what? For DHCP offer message. Is it clear, Athira?
Yes,
Athira,
Prashant,
are you clear
yes.
with this? Now,
Yes.
now I am talking about dynamic ARP inspection. I told you in the dynamic ARP inspection, when the switch is going to receive ARP request or the ARP reply on any of its port, it will be dropped if there is
Yes.
no entry in the binding table, right?
Yes, yes.
Now, what I'm saying is that it is the DHCP server only. It will never get the IP address from the DHCP, right? It will never going to happen. So in the binding table, will the server will have its own entry? Never ever. So for the ARP request and ARP reply, we need to make this port as a trusted port for dynamic ARP inspection for the DHCP server. Is it clear, Athira?
Okay, fine. Yes, clear.
Fine. So now
Thank
move to interface E0/0 IP ARP inspection and trust. Fine. Now, if I try to ping from DHCP server once again, let's see. The ping is still not successful. But if I move to switch, now the switch is saying that it is receiving the invalid ARP reply on Ethernet 0/1. Now let's try to understand this. Now, the switch says that I am receiving an invalid ARP response. RES means response on Ethernet 0/1. Ethernet 0/1. where attacker is connected, which is statically configured with the IP address. And I hope everybody is clear now why the switch is denying the packet, because this user 2 has not received the IP address from the DHCP server. So that means there will be no entry in the DHCP snooping binding. So obviously the switch is going to drop the ARP request or ARP reply, whatever it is going to receive on this particular port. And you can see the dynamic ARP inspection is working perfectly fine. So that means if you configure dynamic ARP inspection on the switch, so you have to configure only that port of the switch as a trusted port for ARP request and ARP reply, where the server is connected, or you can say where your default gateway is connected, basically on that port where the DHCP, where you are not providing the IP address to your appliance through the DHCP server. Everybody is clear with the dynamic ARP inspection now? So,
Prashant,
yes.
I have one query. Actually, can we just add one? Can we provide more ports for trusted ports? More
Yes,
than
you
one
can
port?
configure multiple ports on the switch as a trusted port. You can configure interface E0/1 as a trusted port too.
Okay. So more than one port we can add. In the
Yes,
trusted
you
port,
can
right?
configure any port of the switch as a trusted port.
Okay, fine.
See, try to understand everybody that what I'm trying to just simply, I am just trying to explain you that in a case where you would like that the user who is receiving the IP address from the DHCP server is your legitimate user. Fine. This is the first condition, that is how we are concluding the practical. That's router, that's switch, that's PC. Fine. That's another PC 10.1. It has received the IP address from the DHCP server 10.2. There is another user. It has been configured with the IP address 10.3 statically. It is configured with the IP address 10.4. Let's suppose that this user is a FTP server. Fine. Or any server, any website server, whatever you want to, you can just assume. Fine. Now, try to understand that's your default gateway. So, will you configure your default gateway with the DHCP IP? No. You will always configure the default gateway with a static IP. Right? Now, coming to this server, let's suppose that's the server which you have configured with the IP address 10.4. Now, as a network administrator, you know that on this port of my switch and on this port, my default gateway and server is connected. So what you are going to do, you will configure these port 1 and port 2 with the ARP inspection trust feature. That because on this port or on this port of the switch, they are never going to receive the IP address from the DHCP. So there will be no entry in the snooping table. So you can configure these port as trusted port. However, for the rest of the users, for the users port, you do not need to configure trust command, because you want to make sure your legitimate user or your endpoints should get the IP address from the DHCP server only. And if any user is not being provided with the IP address from the DHCP server, so there will be no entry in the snooping table. And if there is no entry in the snooping table, the switch will block the ARP request and ARP reply. And if the ARP request and ARP reply is dropped, obviously your endpoint will never be able to forward any kind of traffic, because to forward any traffic, first of all, ARP should be resolved. So if ARP is blocked, then obviously no traffic will be forwarded by that particular endpoint. Are you clear now, Ms. Sathira?
Yeah.
Sure.
Yes.
Amit ji, any queries? Santosh ji? Mike, I believe you have joined very late today. Mike, Mr. Mike, am I audible? Okay, let's go ahead. So these are all the configuration of the ARP inspection, dynamic ARP inspection. And now I just need to discuss something called IP source guard. Again, this IP source guard is a feature which is dependent on DHCP snooping. And what does this feature says? That's your router, that's switch, that's user. Let's suppose that's an attacker which is using a static IP 10.10. That's the actual DHCP server which has provided this user as an IP 10.1. Fine. This is default gateway which is having the IP address 10.2. Try to understand. Now, you know that whenever you are going to configure DHCP snooping feature on the switch, what happens? When any user will be provided with the IP address, there will be an entry. Now, what does this IP source guard does? If you enable IP source guard feature on any port of the switch, it says that whenever I'm going to receive any kind of IP traffic, what do I mean by IP traffic? Basically, if on any data or on any packet, if there will be source IP or destination IP, fine. If on any packet, there will be IP addresses on the packet, then switch will check the source IP. Now, if this user is forwarding the traffic with the source IP 10.1, now this switch will check the binding table. Now in the binding table, switch will check what IP address has been provided on this port. If it is 10.1, then this IP address, the source IP address has been verified. So the switch will accept the traffic on this particular port, whether it's ICMP, ARP, HTTP, whatever traffic it is, it will accept the traffic, or else traffic will be blocked. As simple as that. Clear to everyone? The IP source guard feature is going to check the DHCP snooping table, and it will just verify if the packet I have received on the port is matching the IP address which is present in the DHCP snooping table. Just see in our example, in this topology, router, switch, we are using R2 over here as a DHCP server. That's my R4. Now this R4 has received the IP address 10.2 from the DHCP server, right guys? Now try to understand, when this user will try to send any packet, any kind of packet, on any kind of packet, there will be something called source IP. There will be something called destination IP. So when this packet will be received by the switch on this port, the switch will check the DHCP snooping binding table. The DHCP snooping binding table do show IP DHCP snooping binding. You can see the switch says that on Ethernet 0/2, the 10.2 IP address have been provided. As simple as that. So when the switch will receive the traffic on this port, it will check this packet is carrying the source IP 10.2. And yes, according to the DHCP snooping binding table, this is the IP address provided to the user. So now the switch will accept the traffic, whether it's ARP packet, ICMP traffic, HTTP packet, BGP, OSPF, whatever packet it is, switch is going to accept it. Now let's suppose that this user tried to spoof the IP address. This user tried to spoof the IP address. It tried to send a packet with the IP address 10.4. Let's suppose that. Fine. So when the switch is going to receive this packet, it will check the source IP in the packet. Does this entry 10.4 matches the binding table? No. because on this port I have provided the IP address 10.2, so switch will drop this packet. As simple as that. Everybody is clear with this? Mr. Amit?
Prashant, so what's the exact benefit of this IP source? But I'm unable to.
You are not
understand
able
it.
to understand the benefit of IP source, right?
Yes.
Absolutely. I would like to explain you. Just do one favor to all of you. Just please rejoin the session once again, because the session will get end in next 1.5 minutes.
Okay.
Right?
Okay.
Now, so Mr. Amit had a query that what is the purpose of IP source guard? Now, let me just give you the actual logic or the purpose of this IP source guard feature on the switch. Fine. Let me just put the question in this manner. Let's suppose this attacker has received the IP address from the DHCP server. That's your internal user within your organization, right? And if it's your internal user in the organization, obviously it may receive the IP address from the DHCP server, right, Amitji?
Yes. Yes.
So so now try to understand. So if this user has received the IP address from the DHCP server, let's suppose that the IP address is 10.2. It has received from the DHCP server. That means the DHCP snooping feature which have enabled on the switch, it has passed the DHCP snooping feature. There will be entry in the DHCP snooping binding table. Am I right? Also, since there will be entry in the binding table, so that means the dynamic ARP inspection feature, it will also pass. Why? Because there is entry in the binding table. Amit, are you clear with this?
Yes. Yes.
Bas, that's it. Now try to understand. Amit, this user is a legitimate user. It has joined the company. He is working fine with the organization. Everything is going fine. But let's suppose that on some particular day, he had an argument with his manager. Okay. And he changed his mind from a legitimate user to bring down the services of their organization. Fine. So now let's suppose that this user knows some hacking, maybe he knows some how to do some illegal activities. He knows everything. Fine. Let's suppose that. So now I told you, if you would like to perform DHCP starvation attack, Amitji, if you would like to, if this user want to perform the DHCP starvation attack, what it is that when an attacker is trying to get the IP address from the DHCP server, right? So basically what it is going to do, it will send the multiple ARP request and the DHCP server will provide the ARP reply. So basically this attacker will be able to perform the DHCP starvation attack successfully. I understand this. Now let's come to the second attack. I told you there is something called DHCP spoofing. Now DHCP spoofing means when the user is sending the traffic on the behalf of other appliance or on the behalf of other user, right? This is what spoofing means. Now try to understand this DHCP server, or sorry, this user, fine, 10.1, it has received the IP address 10.9 and it wants to reach to the internet. So obviously it will generate the it will generate an ARP request, whatever it is for the default gateway. Now we know that ARP request is always broadcasted, right? Now this attacker would like to give the ARP reply on the behalf of default gateway. So what will be the ARP reply? 10.10, because it has received the IP address 10.2 from the DHCP server. But now it is trying to spoof it. It is trying to provide the packet on the behalf of other device. That's what spoofing is. IP spoofing. The source IP is what? 10.10. Destination IP was 10.9. When this attacker will try to send the packet from some other IP, so will this entry be available in the binding table? No, because according to the binding table, this particular port has been provided with the IP address 10.2. So why this switch is receiving the IP address 10.10? or let's suppose 10.11, why it is with this particular port of the switch is receiving the packet from different source IP. So switch will sense that this user is not a legitimate user because it is not using the same IP address which has been provided by the DHCP server. So it will block the traffic. As simple as that. Clear, Amit ji?
Okay, okay.
Miss Athira, Mr. Santosh ji. Athira, are you clear with this?
Yes, Prashant. Clear.
Ma'am, you are not audible.
Yes, please, it is very.
I'm clear.
So, ma'am, are you clear with this?
Yes, yes.
Okay. Santosh ji, any queries?
No, it is clear.
Fine. So this is why, that's why we have this IP source guard feature on the switch. So the command is quite simple. You can configure, you can move to any port of the switch, or you can configure all the port of the switch with this IP source guard feature. So when it comes to the configuration part, the configuration is quite simple. Let's suppose that in our topology, I would like to configure Ethernet 0/2 port with the IP source guard feature. So interface E0/0, sorry, E0/2, then IP. Let me just check IP source. IP verify source. That's it. This is the only command, and this feature is enabled now. How you can verify? First, you can run this command, do show run interface E0/2. You can see the switch says that on my interface E0/2, this IP source guard feature is enabled. And how you can verify? You can run this command, do show IP verify source. Now you can see the switch says on my interface E0/2. Fine, I am going to perform the filtering. How the filtering? IP based. Because switch says that on this particular port, the IP address 10.2 has been provided. And how the switch got to know this information? From the DHCP binding table. DHCP do show IP. You can see from the Ethernet 0/2, from in the DHCP snooping binding, the switch says the 10.2 has been provided to this MAC address. Fine. That's why in the IP verify source command, you can see that on Ethernet E0/2, switch says that this particular IP has been given using the DHCP. And if I receive packet from any other IP other than 10.2, I will block the packet. I will drop the packet. Everybody is clear to this?
Yes.
So basically in today's session, we have discussed about dynamic ARP inspection. The dynamic ARP inspection, why it is there? The dynamic ARP inspection makes sure that the user which has received the IP address from the DHCP server, only that user will be able to send ARP request and ARP reply. Fine. Again, you can configure dynamic ARP inspection feature only when DHCP snooping feature is enabled. Fine. Then we discuss something called IP source guard feature. Now, IP source guard feature is also dependent upon DHCP snooping feature. And what does it says? The IP source guard feature says that if I receive any packet on my port, I will check if there is entry on that port in the binding table. Now, if I have received the IP address from the same IP which has been provided by the DHCP server, then I will accept the traffic, else I will block the traffic. As simple as that. So that's all.